This is the Building Automation Monthly podcast with Phil Zito, episode 85. Hey folks, Phil Zito here, and welcome to episode 85 of the Building Automation Monthly podcast. And in this episode, I'm going to be talking through 7 tips for troubleshooting your IP controls network. This is going to be the last of the IP controls episodes, and if you recall, I've gone through several different things related to IP controls over the past couple episodes. So we will be wrapping that up and then moving on to another topic the following week. So if you recall, I covered in the last episode, I went through just kind of things you needed to know about IP controls and how to design those networks. Well, last week's episode, unfortunately, I missed it because I was putting the finishing touches on my new course designed for building automation system professionals. And I'll give you some more info about that course in the next episode, but suffice to say, thanks to thanks to Labor Day. I'm trying to remember what holiday it is. Thanks to Labor Day, I was able to go and get all the videos done. So that's pretty freaking awesome. I got that course done and it's going through review right now. So this episode came about because very often I get emails from folks and they're asking very specific questions around how to troubleshoot some aspect of their network. And in all honesty, these questions are difficult to answer because each network essentially is different, and I don't often have all the information in front of me that I need to be able to answer that troubleshooting question. And so when I was thinking about IP controls, I was like, oh my goodness, this is going to be a freaking nightmare for so many folks in the building automation industry because it's like a perfect storm, right? You've got IP knowledge, IP controls that no one really understands, and a lot of the BAS folks don't understand IT. And then you mix in troubleshooting, and then you mix in all this stuff that is just like coming together at the right time to make it really hard. So what I wanted to do was to give you some general principles that would really help you with just troubleshooting your IP controls network, regardless of what your design was. So independent of any design, these principles, if you follow them, are really going to help you go and troubleshoot your building automation system. So the first is tip number 1, and that is to get physical. I wanted to create some tips here that had kind of a memory to them. You could remember these because they're kind of a little funny, a little kind of off in left field, I guess. So get physical. What I mean by that is so often, I'll talk with folks and they're like, hey, help me troubleshoot this VFD, or help me troubleshoot why this relay is not turning on. Help me troubleshoot this, help me troubleshoot that. And oftentimes the answer is the physical wiring, the power. Is it connected to the right device? So when you're thinking about an IP controls network, the first thing you want to check is the physical aspects of it. You want to check the cables. Make sure that the cables are good, make sure they're terminated properly, they're wired properly, all those fun things. Then you want to verify power. One of the things about these new IP controls is that if one of them loses power, then especially on the daisy chain architecture, it's not going to continue that pattern. You can't see me moving my mouse up and down making a daisy chain. I'm like, yeah, just look at that. But I realize you can't see what I'm doing, so envision hop after hop after hop, just like MSTP. But unlike MSTP, that is a powered communication, this is going to need that boost of power at the network interface card on the controller to go and make it work. And then is it connected to the right device? I mean, how often does this happen where you're running a cable and you realize, oh, it's not connected, especially with star pattern with IP controls, where you're doing that. So those are things that you're really going to want to be aware of, the physical. The next tip is it's a map. And I pulled that idea from my kids love to watch Dora the Explorer, and there's this annoying map that hops out of a backpack, and it's like, oh, Dora, to get to step such and such, you've got to go through this mountain and swamp, and you'll end up in happy capsule kingdom place. And I'm like, oh my gosh, shoot me, please. But anyways, let's think about that though. At the end of the day, so much of troubleshooting an IP controls network is dependent on understanding how your devices are laid out. And while we could get some forgiveness with controls networks, especially MSTP because it was daisy chained, IP controls introduces so many different variables. It introduces star pattern, which is a direct run. It introduces wireless controls. It introduces a ring pattern. So there's so many different patterns that can be implemented, and those are design patterns, that if you don't understand these, you could be troubleshooting issues that aren't really issues. And so really you need to understand how those devices are laid out. And then you need to understand if there are any boundaries that would prohibit communication. And I'll do more on this in tip 4, but the reality is there's a learning curve for IP controls because you're going to be going from MSTP controls where all the points, all the data, all the communication was essentially reconciled at the supervisory device, right? The field trunk connects to the supervisory device, and the supervisory device takes all that data, converts it to whatever upstream protocol it's using, HTTP, IP, etc. Well, when you're using IP controls, you don't necessarily have the supervisory device doing that anymore, depending on the manufacturer you're with. And so now you're talking about a greater reliance on BBMDs, you're talking about routing, all sorts of other things. And like I said, we'll discuss that in tip 4, but you really have to understand those boundaries, both the physical boundaries of the network as well as the logical boundaries. A physical boundary would be a switch that separates one layer 2 network from another, whereas a logical boundary may be a VLAN or something like that. Tip 3 is conflict resolution. That's where you go and resolve conflict with your coworkers. But in all seriousness, conflict resolution is really important because, especially with IP controls, with the non-IP controls, MSTP, LAN, etc., you could use, well, maybe not LAN. LAN did have unique neuron IDs. But at least with BACnet MSTP and with Modbus, you could use registers or MAC addresses that were unique to that network segment but weren't unique overall. But when you start to get to IP addressing, now you're starting to deal with things where you have to have unique IP addresses, at least in the private subnet class that you're using. And then you have the whole other variable is your list of addresses correct? I see a lot of vendors recommending DHCP, which I totally understand, because going and applying IP addresses to 1,000 field controllers would be like mind-numbingly boring for one, and would be a recipe for mistakes. So I get why DHCP is used, but then when you're using that DHCP pool, are you actually using accurate IP addresses? Are you going and creating a DHCP pool that is accurate? That's something that is really important for you to go and understand, because if that pool is not accurately reflecting what is implemented on your network, then you could be in for a world of hurt. So you really have to understand that, because one of the biggest issues with IP networks is conflict, IP address conflict, and that could cause some huge problems for you, especially if your IP addresses are intermingling with other systems that maybe aren't BAS controls. That's why I really recommend segmenting, at least on a subnet, your BAS network and not mixing it with a production network. So that's a whole nother thing that you need to think about right there. All right, tip number 4, follow the yellow brick road. So if you think about it, right, if you created a map like you should have done in tip number 2, then it's time to follow that map to the pot of gold, or at least to the problem. So when I say follow the map, what do I really mean by that? Well, how I often will go about troubleshooting problems is I will start at the device that is having issues, and then I will follow that device, and I will follow it along the path to make sure that it is going wherever it's supposed to go. And then as soon as I see a deviation, that will help me go and pinpoint the potential issue. Now, at this point, you may be saying to yourself, okay, Phil, but what issue are you pinpointing? Well, there's really two main issues when you're working with IP controls. Now, sure, there are plenty more issues. There's all sorts of stuff like NAT resolution and proper VLAN segmentation and all just craziness. But the main two issues that you're going to run into that are going to stop your network in the tracks are going to be route boundaries. And what I mean by that is you've got one network, one subnet, and you got another subnet, and you need to use an IP route because remember, IP is a routable protocol. And you need to use IP to go and route from one network segment to another network segment. And those routes, maybe they get changed, something's been broken. We'll talk a little bit more about that in tip 5. But the bigger one is BBMDs. And so basically, BACnet Broadcast Management Device consists of a table of network segments that have BACnet devices on it. And essentially what you need to do is you need to go and populate those tables so that then the devices know where to communicate. But you also need to have a BBMD in each network segment to go and forward traffic, because BACnet is a broadcast protocol, meaning that it uses these messages like who is, I am, those kind of things, and they get broadcast across the network. Well, broadcasts can't leave subnets. And if some of this stuff, if you're like, Phil, you're talking about subnets and broadcasts and all, I don't understand this stuff. Well, then I would recommend you go look at some of my other, or go listen to some of my other podcasts on IT where I will definitely discuss that. And those are previous episodes, and you can find them just in the list of episodes. And go listen to them, especially the ones on networking. They'll help kind of bring this to light, help you kind of get on the same page of where we're talking right now. Now, with that being said, I'm going to come back to our regularly scheduled programming now. All right, so here is what I mean by that BBMD. So you've got those BBMDs, and you've set them up in the network segments. Well, sometimes something happens, and you lose one of the BBMD IP addresses, and then all of a sudden your BACnet messages are no longer being routed. So it's really important for you to understand that as well. And it's also important for you to understand that those BBMD tables, they need to be on devices that have static IP addresses. You don't want your BBMD being assigned a DHCP address. That would really mess with things. That get really ugly really fast. Which brings us to tip number 5. Your GPLS signal has been lost. Have you ever been like driving, or maybe you're in a city, you go in a city and you're using your GPS to walk around and all the buildings are blocking, and it's like your signal's been lost, and you know you're halfway to wherever you're going, and all of a sudden it's like spinning in circles, and it's like, you know, you're standing on a piece of magnetic ore or something and it's causing the compass to spin. Well, it's just like that. And IP controls, they introduced this concept called routing, right? I talked about this a little bit, but I want to go into greater detail. Essentially what happens is when a message leaves one network segment and goes to the other, it goes to what is called a default gateway. And that default gateway is typically a router. And that default gateway will say, hey, if you don't know how to get to this IP address, you come to me. And then I have a route, and I say, oh, you want to go to this IP address? You need to go out this port. And basically that's how the whole internet works, right? It's a series of routers that take traffic from one network segment and move it to a different network segment using routes. Well, unfortunately, we live in the world where there's people, and people make mistakes. And so I've seen this actually happen quite a bit, where IP routes are essentially deleted or changed, or maybe you're using a routing protocol and it messes things up, and it changes those routes, and then all of a sudden your network traffic is not working. Well, that's something that's really important to be aware of, and it creates a really interesting conundrum, because it's not like, you could just log into the Cisco router and start checking IP routes. Unfortunately, the reality is outside of a lab, you're probably not going to have access to the IT gear. And so therein lies the rub. You got to be able to talk to IT. You've got to be able to understand routing. And so you've got to be able to go and kind of figure out that this might be a problem. And there's several different ways that you can do this, some of which are things like using tracer T, which is a command that you can use in command prompt. You basically see where your signal stops, and that kind of gives you an idea like, oh, it gets to the router and then it dies. Well, I wonder why. I wonder if there's a routing issue. So basically right there, you've got an indication of a routing issue, and then you've got to go troubleshoot that. So that's another tip that you really want to focus in on. Which brings us to tip number 6. Your access has been denied. All right. Well, here's the thing. Overzealous network admins and cybersecurity professionals rejoice because you have managed to break the connection between the air handler and the chiller. And that is the future we live in, right? So you've got this IP control on the chiller, you've got an IP control on the air handler, and all the air handler's valves are going and driving a reset maybe on the chilled water set point or something like that. And wouldn't you know, someone decided to change a route, or someone decided to put up a firewall or some sort of proxy or something, and now it's filtering traffic and it's blocking that traffic, and all of a sudden the network connections are dead. So therein lies a rub. How do you know if it's a routing issue or if it's a firewall or intrusion protection or some sort of cybersecurity filtering issue? There's no real easy way for you to know that, because if you're looking at it from a traffic perspective, your responses are going to look the same. Your stuff's just going to bounce back when you do your tracer T or when you do your ping. It's just going to bounce back as unreachable network. And so then you've got to get involved with IT. If you get unreachable network, you've determined one of two things, right? You've determined either I've got some sort of routing issue, because you've already checked the physical stuff, right? Because that was tip number 1. So you've got no physical problems. So it's either a routing issue or some sort of cybersecurity issue. So right there off the bat, you need to go and make sure that your access is not being denied, that you aren't being blocked. Which brings us to the last tip, tip number 7. And this is called don't let them shut you out. Back when I lived in Dallas, before I moved to Milwaukee, there was this tollway, and it was called Dallas North Tollway, and it then went on to this other tollway called 121. And or was 120? No, Dallas North Tollway is a tollway. 121 I don't think was a tollway. Maybe it was. I don't know. You folks in Dallas, correct me if I'm wrong. Anyways, the point is, sometimes I would come back from business trips, and it would be late at night, and I'd leave DFW, and I'd head up north towards my house, and I'd be flying. I'd be going like 90 on the tollway. And yes, I know you shouldn't be going 90 on the tollway, but you're not my mom, so don't need to worry about that for me. I'm going fast, and I get off, and I go to my Taco Cabana and grab my beef fajitas and my queso, and everything was great because there's no traffic. I was just flying. And then there were other times where it's like you're in the middle of New York during rush hour, and it was super slow. If I tried to hop on that tollway at 8, 9 o'clock, it was bumper to bumper. It was packed. Well, networks can be like that too, depending on how you're messaging your traffic, depending on how you're going and broadcasting your messages across the network. You could go across what's called a trunk, and it could be very congested, meaning a lot of traffic. Because ultimately, these cables that connect different network pieces of gear, they're just cables. They can only send so many electrical signals over them at a single time. So they've got limited what's called bandwidth. They've got limited capacity to transfer data. Well, if you just so happen to have your building automation system going across the same trunk that, let's say, someone streaming the latest HD episodes of Game of Thrones across, then you may eat up all your bandwidth. That may be eating up all your bandwidth, and you may not have enough bandwidth, in which case you run into what's called a quality of service issue. And what that means is that certain traffic's going to be deemed more important by the switches than other traffic, and so the less important traffic goes into the trash can. Unfortunately, BAS manufacturers have not seemed to realize that they can tag their BAS traffic and make it at a higher priority than other traffic. Otherwise, they would have done that, I would hope. And that would make things to where your traffic can communicate and not fall off into the middle of the earth. But until that happens, that's something you need to be aware of, because if you start to see time-based traffic losses, time-based communication losses, where it's like, every night at midnight I lose communication to the BAS. Well, I wonder why that is. Oh, there's database backups going on at that time. Oh, well, that's interesting. Then you can start to go and put strategies in place, maybe using different trunks, maybe going and having different routes, a variety of different things to make sure that that BAS traffic still gets across the network. So it's really, really, really important to make sure that your building automation system is not getting shut out by quality of service. And so with that, I deem this IP controls conversation complete. Or at least until more stuff comes out. But that should take care of you, right? You should have an understanding of what IP controls are. You should understand how to engineer them and design them. And then you should understand, at least at a high level, some principles around controlling or troubleshooting them. So I've got two really cool pieces of news for you. It looks like, and actually when I wrote these show notes, I wrote it looks like, but now that I'm actually reading my show notes, it actually is that I've finished my design for BAS course, and it's just in review right now. So the early adopters of the course are taking a look at it, providing me feedback, and then I'm going to release it to the market, which is awesome. And I'll talk more about that in the next episode. But that means I'm going to be reopening my IT course even earlier than I thought. I thought this design course was going to take me until January, but it just flowed naturally. I don't know how. I just sat down on Labor Day and just started recording, and that weekend it just kind of poured out, and bam, I was done. I was like, oh, wow, that was kind of cool. So that means I've got bandwidth to work on my IT course again, and my IT course is going to be opening back up, which actually is really perfect because I've had a lot of you emailing me about that course saying, when's it going to open back up, because we're installing IP controls, or we're having to deal a lot more with IT, and we really need this, and there's nowhere to go to get it, and we need this information. So if you've been interested in learning the fundamentals of IT, but the idea of spending thousands of dollars to travel to some boot camp, or go and get a master's degree in IT like some crazy guy who runs a podcast did, I don't know anyone like that, by the way, then I've got the perfect solution for you, because I've got my IT course. It's rolling back out to the market. It's an online, self-paced, 100% online, lifetime access video training program. And you're going to learn exactly what you need to know about IT, because it's what I've learned you need to know about IT over a very long and painful career learning things the hard way. So you're going to learn everything you need to know in days, not years, and increasing your ability to communicate with IT, install and troubleshoot all of the new IT gizmos and all the other stuff that is being sold in the BAS world. So you can find out more about that. You can read the show notes for this episode, And you can find out more information about just everything Building Automation Monthly in general by going to buildingautomationmonthly.com/85. Once again, that is buildingautomationmonthly.com/ the number 85. And if you want to know more about this IT course, then just scroll to the bottom of the page and click the IT for BAS is open link. And with that, keep on trucking, keep on learning, keep on stretching your knowledge. You can know and do more than you possibly believe in right now. The only limitation is what you hold yourself to. So I'll talk to you next week. Take care. Talk to you later.